Hey Kickstarter, I'm Patrick McFadden. For the past 11 months, we've been developing what we believe to be the world's first affordable force feedback or control loading simulator yoke. Most people are probably familiar with force feedback joysticks and other haptic feedback technologies. However, up until now, force feedback yokes have really only existed in the domain of industry. The core concept of a force feedback yoke is to allow the user to feel how much force they're applying to the plane's control surfaces, specifically the elevator and to a lesser extent the ailerons.
In 2010, we were asked to design a very specific class of flight training device. While we were sourcing components, it became clear that there were no affordable force feedback control yokes on the market. So we thought there has to be a better way, and when there wasn't, we decided to make one.
Existing systems have complex internals, which probably has something to do with their cost. So we figured the only way to bring this to the wider market was to develop a much simpler actuator design. And quite frankly, what we've come up with is like nothing else out there. The yoke's shaft consists of an aluminum tube lined with strong magnets. These magnets then pass through a stack of electromagnetic coils. By manipulating the current in each of these coils, we can impart forces on the magnets, which in turn gives us amazing static and dynamic forces, all without expensive pulleys, slide bearings, pneumatics, or hydraulics. Now, to make this whole thing work, we needed hyper-accurate position tracking. So we turned to a two-prong approach, using both magnetic Hall effect sensors, along with a very high-resolution optical mouse sensor. This gives us accuracy, factors of power beyond that of current consumer products.
For the pitch axis, because you don't have a torque mechanical advantage, when you're using a stepper-based motor or a servo-based motor, you can experience graininess when you move it in and out because you have to spin over the motor. So the benefit of this method is that there's actually no physical contact with the yoke. We use all our force using magnetic fields, and that eliminates a lot of friction, but more importantly, it eliminates that graininess that you feel when you're rolling over an electric motor.
The system will obviously support USB, but more interestingly, it's being designed around TCP/IP. This means that you won't necessarily have to have your computer directly plugged into your yoke. Rather, the yoke can be attached to your home network via Ethernet. And of course, if you're using TCP/IP as a communications protocol, it doesn't matter if you're on Mac, PC, or Linux. Driving the logic side are two open platforms, an Arduino-based microcontroller for power handling, and the massively popular Raspberry Pi to handle interfacing with your simulation software, computing force data, and as a platform to serve a web-based configuration menu, much like you've probably used for your home router. We're working around a modular design, which is built to be both extremely reliable and upgradable. Our hope is to have a device which is as future-proof as possible. We have most of the initial tooling and assembly space already organized, as final assembly will be done in Canada using as many North American suppliers as possible. Now, the simulation community is pretty diverse, so a key tenet of everything has been open architecture, allowing every bit of software and hardware to be tweaked, modded, and upgraded as you see fit. So, if you wanted to replace the $5 hat switches with $100 Hall effect thumbsticks, it'll be as simple as plug and play. If you want to extend or shorten the throw lengths to accommodate a custom panel design, our diagrams will show you how. We have a functioning prototype. We have a design which can be put into production. We have vendors lined up, and we have a development team in place ready to take the software past the alpha stage. But we need your help. There is no way a product like this will see the light of day without community support. So please, if you're a dedicated flight simmer, if you're a student pilot, if you're a licensed pilot, if you operate a flight training unit, or if you're just interested in adding a previously unaffordable level of realism to your simulation experience, please click the button. Pass the link along to anyone you think might be interested, because without your support, this project is grounded.